How was everyone this afternoon? Still awake? We're going to get out of the clouds a little bit and a little bit back here on Earth, or on the ground at least, talking a little bit about unit testing and some practical lessons and practices that I think you can apply to anywhere you do unit testing, any platform, anything you can do. I'm going to do it in C#, but you could apply this to any platform that you're using or doing, because a lot of people do that these days. So, a little bit about you. I'm going to make an assumption that you probably know C# because there's going to be a little bit of code in the slides, are at least interested in unit testing and are not afraid of code. How many people do unit testing today? That's a good bit. Half of you. Half of you. I'll say that's half. It's a rough estimation. And I am Scott Densmore. At least that's what they tell me. I work in the Patterns and Practices group here at Microsoft. How many people know Patterns and Practices? I like to ask this question because one day I asked, and it was like everybody raised their hands, and I was amazed. I was just amazed because it's usually about a third or half of the people know who we are. I do a lot of my time the last couple of years doing Azure development and working on best practices for Azure, but we're not going to talk about that today. Everything you want to know is just in Brian's talk about Azure. And so that's a little bit about me. That's about you. Let's try and get started. Here's what we're going to talk about today. What is unit testing? A lot of you probably have an idea about what unit testing is. I'm going to try and explain what I think unit testing is, and a little bit about some practices and lessons that I've learned over my many years of unit testing. And before I get started, I do want to tell one story, because I always like to start off with a little bit of a story. And it was actually 8 or 9 years ago. When I first started at Microsoft in PMP, we were working on this product called Enterprise Library. How many people have heard of Enterprise Library? Okay, about the same number of people that have heard of Patterns and Practices. Big surprise. So we were working on Enterprise Library, and we had lots of tests in our code. I'm not going to say they were great tests, but we had lots of tests in our code. And one day I was trying to check in, but I couldn't get a test to pass. It was actually some kind of threading piece or some kind of interesting problem, but everybody kept coming into my office and going, well, let me help you with that. Well, let me help you with that. And let me help you with that. And I was like, I don't need any help. I can do this myself. Well, about the 10th person that walked in the room happened to be Jim. And I just about had enough of people trying to help me. And it went from, can I help you with that, to slamming the keyboard down, keys flying, no, you can't help me with that. But the lesson I took away from that is that... By the way. Huh? I was not injured, by the way. Yes, you were not injured, by the way. The lesson I took away from that is that, and one of the things I've always known is, if your test is not passing, something's wrong with your code. And don't check it in, because the next person may not slam their keyboard down on the desk. They may come up behind you and slam the keyboard in your head. So, you never know who's going to look at your code next. I promise you that. So, let's talk a little bit about what unit testing is. So, there's all different types of testing. It's almost like an alphabet soup. There's, test-driven development, behavior-driven development. I've got my guys in QA doing testing. I've got all kinds of these interesting things going on in the test space. But when I say unit testing, what I'm really talking about is down here. Let me look how you guys are looking. The left-hand side, down here on the bottom, these programmer tests. You can call yourself a programmer, developer. They call us engineers, however you want to say, but think of yourself. But this quadrant kind of explains all the different types of tests. There's these customer-facing tests. That could be some kind of behavior-driven design tests, or there's these exploratory tests that maybe my QA department does. They go and click the buttons, or they write automated scripts to have links clicked or whatever on my website. Then I have these functional tests, these ilities that test all the scalability and performance things that Brian probably talked about. And then down here on the bottom, this is where I live. I'm a developer. I live down here in this bottom. And what is this to me is this unit testing, is how, when I'm developing my code, what is the test I'm going to write to make sure that it passes? I do my test first. You may not do your test first. I would suggest that you always do your test first. Why? Because if I write I will only say this on my behalf. Because if I write that code that does A plus B, I already know what A plus B should do. So what am I going to do? I'm probably going to write a test that tests about what I think A plus B is going to do, because I already know how it works. So I'm going to say if A plus B equals 2, then I'm going to probably write a test that, hey, assert that A plus B is 2. And if I say beforehand that A plus B is 2, I can say I want to make sure that happens beforehand. I can do that. So that's all I'm going to say about test first. I would suggest that you do it, but you don't have to. But you will find that your design comes out a lot better with test first. So these are a lot of quotes from Kent Beck. If you don't know Kent Beck, you can go up to the Google or Bing or Google that with Bing or however you want to do that and find that. But what they're saying here is, a lot of times, how many people spend most of their time writing brand new code? I want your job. Actually, probably everybody in the room wants your job. I mean, if all you ever do is write new code, that is awesome. Now, I would suggest that you write tests for all those codes because you never know who's going to be looking at that afterwards. But those of us probably, most of the time, spend most of our time building on code that already exists. And most of the time that we do that, what are we doing? We're reading through that code going, what the... Are you kidding me? No, that's not... What does I stand for here? That's what most of your life probably feels like most of the day. And when you do that, you're like, well, how can I verify that what I think is going here by reading through this program is actually happening? How do I understand what's going on in this code? Well, I'm pretty good. I can read through the code and I can think I can figure it out. But most of the time, what do? Well, if you're in Visual Studio, you go like F5, depending on what your settings are. F5, breakpoint. Yeah, yep. Okay, I got it now. So most of your life is spent in the debugger and reading code. How many if I just described your life, raise your hand. And this is all about raising your hands to keep you guys awake. So you're going to raise your hand a lot. So I don't spend a lot of my time in the debugger. And I'll explain why here soon. So what I just explained is pretty much this. Except for this guy right here in the front. We should have like the camera come and focus on you and say every time I go, except for this guy. Doesn't have to deal with this reading through code and maintaining this existing code that's already out there. I've got this program that now I've got to change or add features to. Most of your life is I spent this much time developing it, and now I'm going to spend all the rest of my life extending it and maintaining it. Because, just a lot of new things under the sun. So, all that being said, that's kind of what we're going to talk about in unit testing. And how many people kind of have followed me so far? You guys are with me? You with me? Okay, you with me? Well, that's great. But now what do I do? How do I go about making sure that I write tests or code that now I know can be tested? Because I've probably seen more code than not that I go in and say, wow, I'd like to write a test to, instead of hitting F5, my goal is not to hit F5, step through the debugger and see what the code says. I want to write a test that says, how can I write a test to prove that what I think is going on in that code is actually going on? Because I probably got some bug assigned to me that says, hey, this is broken, you need to fix it. That's what the tester said, because he went to the button and clicked and nothing happened, and he's like, well, this is broken, I need to fix it. Well, now I got to figure out what can I do to try and verify that that's really broken and what I think is broke about it is actually broke about it. Well, this is where writing unit tests come in. I can go in, write a test, and say, all right, here's my expectation. I expect that when I, do this, click this button, the thing that's going to happen is nothing. And I can say, yes, that's exactly what happened. Or something else happened and I learned something more interesting about the program. But let's just say that nothing happened. But then I could write a test and say, or change that test and say, what I really want to is when I click that button, I get an answer of 42. Because I expect 42 to come out of the click of that button. So what I'll do is I'll write a test, I expect it to be 42, and then I can go write some code, and yes, I could just return 42. But I could go look at that code, start working at it until that test passes. And once that test has passed, and we'll talk about how we can write some of these tests, once that test has passed, I can then say, I feel confident that this code works exactly the way I expect it to. So this whole test-driven development and behavior-driven development and things like that, these tests are the expectations that I have about this code. And when I can prove that this works, I can then check that in. And I do that a lot. How many people check in after every test they write or after everything that works just perfect because they don't want to spend all day with the code files checked out because people come around and yell at you about why do you have that file checked out? So I write my test, it passes, I check in. Start back at the beginning. Write my test, I write the code that makes it pass, I check it in. It's that simple. And if you can keep that cadence going all day long, you will feel much more confident about your code. Because the first thing you're going to worry about is you're going to break something. People are like, oh, I don't want to write unit tests, I might break something. But I will tell you, if you go through the scenario I just gave you, something's already broken. How many people spend most of their time fixing code that somebody else wrote? Only a few of you. The rest of you, I want your job. Because, again, you spend a lot of your time fixing things. A lot of times I spend time fixing things that I broke. But that's a different story. So if I go out and write these tests, I feel confident when I check that code in that it's doing what I expect. Now, I'm not going to say that it's doing what everybody else expects, but at least it's doing what I expect it to do. If I understood the requirements, from the people person that handed me the requirements, that said, this is what it should do, and then I write the code to make it do, actually, write the test, then write the code to make it do what it needs to do, everybody's kind of expectation is met. And you're not breaking anything. Even when you start with a large code base, when you're starting to write unit tests, write one. Say you got a code base that has none in there. Figure out how to write one. Because you're probably something's already broken. You want to verify that it's broken and works the way you expect it does. And then you want to write some tests around, how do I make this and fix this? And this kind of leads into, where do I start? You start by writing that first test. Just one. It only takes just one. And it's like crack, you give them one, and you give them another one, and eventually you have all these tests, and then you feel confident about your code. And when you start feeling confident about your code, it's like walking the tightrope. Who wants to walk a tightrope without a net? This guy. I'm going to pick on you. Sorry. It's just the thing I do. Nobody wants to walk the tightrope without a net. It sounds cool, but if I fall, I don't want to die. And again, I want to make sure that the code I write works, because I don't want the axe-murdering coder that they hire the next time to come looking for me when my code doesn't work. So I want to start by writing that first test. You write one, you write another one, you write another one, and eventually you will start feeling confident about the code that you write and the code that's in your system. And once you get that confidence, the thing that you will learn too is making changes are easy. They're not hard anymore. So when they go, hey, can you do this new thing and change the way this thing works? You'll be like, yeah, no big deal. Whereas right now you're like, whoa, 6 weeks, 9 months. It's compiling. That's for all you SKCD guys out there. All right. So the thing I can tell you is just do it. Get your code out there. Write that first test. Go out. Spend a little time. Feel confident. And it'll get it done. So this brings us to our first lesson. That's using the 3A pattern. So I'm going to talk through 6 lessons about how you can write these unit tests and what they could look like. And you will, especially for those who have never done it before, this will be kind of the ground setting pieces. You can go out and start working through other different ways of doing testing, but these are the kind of practical things that I've done ever since I started unit testing. Another quick aside, I've followed this couple of grand poobahs, Ward Cunningham and Brian over there. I used to work with Ward at PNP for a couple of years. And I actually, Ward probably doesn't know this, I didn't really know who Ward was when I first. I mean, I'd heard a lot about him and knew all kinds of that he was this awesome dude. But I thought he was just another guy. And I remember him coming into my office one day, and we sat down and we started writing some tests, and we started talking about how we can, what the code should look like from this test and those type of things. And that was an amazing experience. And I learned a whole lot from that. And some of these are the things that I learned. And some of these things I learned from Jim, some from Word, but from all the people that I've worked with. Because even though you're sitting in your cube or your office all day long writing these tests and those things, the other thing you need to do is walk around to some of your friends and help them write tests. Help them I do the dumb thing. I will ask, and you probably do this already, you don't even know it, but I will ask people, I don't know how to do this, can you come help me? Even though I may know how to do it, I still kind of act dumb and play dumb and say, can you please help me? And that way I get this whole some people don't like this whole idea of pairing, but I do. Pairing exercise going on. And once you do that pairing exercise, you learn more from the people around you. And the 3A pattern is one of the things I learned from another guy, Brad Wilson, that I worked with, and it's one of the things I've always done ever since. So what is the 3A pattern? First, the 3A pattern is act, assert, and arrange. It was originally attributed to a guy named Bill Wake. You'll have all this deck, so you can go look that up if you want to. So arrange is really this idea of how do I set up this test? So when you start thinking about I'm going to write some test, how do I set it up? And then I want to make that action that I'm doing so that I can then assert the result that came back from that action happened. So let's look at an example. You guys all can read that? Good. This syntax is using XUnit. XUnit is a product that was built by Jim Newkirk and Brad Wilson. So this uses its syntax. But you can do this with any testing framework if you like NUnit, MS Test, XUnit. I think there's about 300 other flavors out there. Pick your poison. I personally like XUnit. And I think tomorrow you guys get to see the new testing stuff with Visual Studio 2011 with Peter Provost. I would recommend you doing that because he will show you how that all works now within Visual Studio. But we're going to have this is a pretty simple stack. A stack of strings. And the reason this 3A pattern helps you is because, look at that. I bet you can already name off all the things that are going on in here. I can arrange, this is my setup. I'm basically arranging up how I'm going to set up this test. So I need to create a new stack, and I need to push something on it. Because I'm asserting that if I look at the top thing, it's not going to pull it off and make sure what I'm saying is it's not empty. Then I'm going to do that act, which is just check the top thing in my stack. I'm assuming everybody knows how a stack works. If you don't, please look it up after you leave. Then I'm going to assert that stack is not empty after I've checked its top element. So all I've done is I've done some arrange, an act, and assert. And the reason I love this, and this is good advice, and it took me a while to figure it out, is because then it makes, you can look at this code and read it. Remember, we go back to some of the previous slides. You spend a lot more time reading that code than you do writing the code, except for this guy. So you can say, I am going to be able to read that real easily. I know that I need to do top. These are the things I need to do. You don't necessarily have to push anything on there, but we are because we're testing that we're not pulling anything off of there. Because you can see, top does not change the state of the stack. It's another one of those tips. Name your tests. Don't name them test 1, test 2, test 3, please. Name them to match what you're trying to do here. And if you do that, what you don't end up with is tests that are, 500 lines long. How many people have seen tests, but they're like so big, you're like, I can't even touch the test? Well, good. Only a couple of people. Good. Maybe we've moved on past that. So why do we do this 3A certainty? I can read it, just like you saw. I can read what's going on. They become consistent. When I open up those code files and look at those tests, I know exactly what I'm looking for. So consistency, being geek, I like consistency because I like systems. I like know exactly how things work. I get weirded out. My wife doesn't like it when she throws a curveball at me because I get a little weirded out about why things don't work the way I think they should work. But there are some liabilities. They have become more verbose. You might need to introduce a lot of local variables to kind of deal with your test. We'll talk a little bit about how you can solve that problem. And then there's some related issues about one assert per test. So a lot of times I like to just have one assert per test. I don't want to test a bunch of things all at once. Sometimes people don't like that because they're like, well, I'm already here. I have to do the same thing over and over again. But if you name the test correctly, you have to sit there and ask yourself, am I testing the same thing over and over, or is this test only testing the thing that I'm looking at? So you've isolated this thing down. I can then go, all right, this is what I want. Sometimes you end up with a couple of asserts in there. That's okay, but if you start having 4, 5, 10 asserts in your test, it's probably a smell that something's going wrong there. So let's talk about the next one. It's a little bit harder to read, but keep your tests close, just like your enemies or your friends or whoever else you want to keep close to you. So keep your tests close. You want to make sure that whenever I'm looking at this code, because if I'm looking at a class and I'm looking at it and I'm going, well, how does this work? And maybe I don't understand the API or interface or how I'm supposed to interact with it. I want to go find a test that shows me how to use it. That's the first thing I go look for. It's like, all right, now that I've done testing for so long, the first thing I start doing is like, well, where's the test that shows me how to use this thing? Because I get it. I don't hit F1 and go look at the API docs. That's, that'd be too easy. I start looking for tests going, all right, where does the code that shows me how to use this thing? Because I think that's things what I'm going to probably trust more than documentation. Because that's runnable documentation that I can use to test, to make sure that things are working as I expected. Because documentation gets out of sync sometimes. So I like keeping the tests close. So if they're close to where your code is, that's good. Now, some people say, oh, well, I have it in a separate assembly. That's cool, too. Then you come up with some maybe naming convention hacks or ways of doing your own things. But that's all up to you how you do it. But make sure that they're close to the actual code that you're testing. What that gives you is, tests are equivalent to production code. You wouldn't want to write some code that broke a test and check it in. Because then you're basically wiping out your net from your tightrope. Now you're just saying, hey, it's okay. We'll just throw those away and it's not important anymore. Because if you keep doing that and you get into that habit, you're basically saying, I'm going to torture my net and I'm going to keep walking down this tightrope. And I don't know about you, that just doesn't sound like a good idea to me. And if you keep your test closed, it does solve that visibility problem of, hey, if I want to go find out how to use this thing, because there's 4 people working on this code base, maybe there's 100 people working on this code base, depending on what team you're on. How do I go find how to use this class? Because it might be interesting for me to use that class instead of me writing my own. And I will tell you, I am much more likely to reuse something that has tests than not. So there are some liabilities. Should you ship your tests? I remember in the IntLive version 1, we went through this whole thing of doing pound defines about if we should, we kept them so close they were in the same file sometimes, and sometimes they were in files right next to it, right in the same assembly, and then we would compile them out depending on what you were doing. I don't follow that pattern so much anymore. It's more of like, here's my actual project name foo. Then I create another project named foo.tests, and then I kind of name the fixtures. The name is the same as the class. So if I have bar.cs, then I might have bar.test.cs. That's just me. That's just the way I keep them close. That way I can kind of find them. It's just my pattern and then I can use pattern matching inside of Visual Studio or ReSharper or whatever you're going to use to find those tests. And then, again, this is how I separate my things out. We actually did ship those. And do you ship your tests? I would say if you're running an open source project, for sure, yes, you should ship your tests. I know that we, in Patterns and Practices, ship all our tests with all of our stuff. Mostly it's reference implementations. Even libraries that we build, like Enterprise Library, Prism, things like that, we ship all the tests with them. We find that because, I will tell you the reason we do that, is because if you wanted to own that code, maintain it, extend it, do anything with it, how would you know that you didn't break anything? You wouldn't, unless you ran the tests. So that's why shipping the tests is a good idea. We at Microsoft don't normally do that because we ship a bunch of shrink wrap products, but overall, shipping your tests is a good thing. So number 3, expected exception can lead you down the path of uncertainty. Now, how many people know what expected exception is? Those people that are still awake. Good. All right. Yes, it is supposed to be entertaining just as much as informative. Best joke of the day, so don't expect any more. So expected exception, the first problem with this is it violates the 3A pattern. So we go back to our previous practice. You could call them rules. If I do something like this, how many people have done something like this? I've done something like this and run it. And this is, just by the way, this is the keyboard, me breaking the keyboard. This is actually what caused it. And I'll explain why in just a second. So now this tweaks my geekness because now that doesn't follow my pattern. Now I don't see where's my assert? What happened here? Well, all I see is you did do an arrange, you acted on it. What happens? Oh, well, you're saying that you expect some kind of invalid operation exception. Okay. Maybe I could live with that, but not really. A better way to approach that problem is to record the exception. is to say, and this record exception, this is a way to do things you can do in XUnit. You can actually do this in any type of unit testing framework. You might have to add a little code to do this. We did this with MS Test as well. But this helps you keep with your geekness and say, all right, now I say, all right, stack, new stack. I'm going to try and do something. I'm going to pop off an empty stack, and I'm going to get an invalid operation exception because there's nothing in there to pop. Probably not the right thing to do. Not the best design. You probably don't want to throw an exception just because there's nothing in there. But maybe you do. That's totally up to you. But now I can record that follows my 3A pattern. Pretty easy. You could also use assert.throws. This one does some stuff, but because it has a delegate, it kind of follows the 3A pattern, but I like the other one better. Just because I'm kind of weird and like everything to look consistent. You can do something like this, where you can say, assert.throws, your action's really at the end, your assert's kind of at the beginning, but your setup is still up there, your range is still up there. But you could also do something like this. This is a little bit of syntactic sugar to say, hey, I expect a invalid operation exception when I call that method. XUnit does this for you. It basically sets all that up and then calls that delegate for you when it runs the test. But there are other problems. This is the problem that I was alluding to earlier. So I expect an argument exception. But in this code, can you tell me where that argument exception gets thrown? No takers? Give me a shot.
Well, you can tell where they thought it was supposed to occur.
Yes.
In the second one, because if it occurred in the first one, the second state line wouldn't ever get executed.
Exactly. So what he said was, the assumption was, and again, all these steps are validating assumptions that you make, that second line was going to throw an argument exception. What happens when the first line does? It's still going to pass. And guess what? It never hit that line that you thought. So guess what you're back to? Set breakpoint, F5. No. Oh, man. So expected exception was actually the cause of my grief. That's exactly what happened with that little story I told you, is that I ended up, that first part got switched around in the code somehow, but that test kept passing because it expected an argument exception. It was just by happenstance that we chose to throw the exact same exception, but it just kept passing. And because I used my test as my tightrope, I assumed that everything was copacetic. It's all good. Everything works. Until the tester goes, not working. But why isn't it working? Don't know. That's your problem. So I spent a lot of time figuring this out. And I refuse to ever use expected exception again because that one incident. But you can run into this problem with expected exception. If I would have done something like this, I would have known exactly what would have happened. Because A, that test would have failed the first time it hit that first line on the checking account when it threw an argument exception, when I tried to initialize it. And the test would have failed. It wouldn't have passed just by happenstance. Because now I'm actually testing the thing that I actually care about, which is that account.deposit. Because if you read the test, deposit throws argument exception when 0. Even though the other test passed, it wasn't really testing that. You also have introduced this little bit of, because the checking account, we assume we are going to arrange it correctly. But that could change over time. Remember, these tests are there to help you know when you break your code. Because you should feel free to change what you want, because we build software. It's the whole idea. We don't build hardware. We build software. We should be able to change things willy-nilly, although the PMs don't agree with us. But hey, whatever. So this also can help you improve. This is where I've got a couple of asserts in here. Improve the control flow. I can record that exception. I can say, I can also do that I got the right message. So if you're interested in messaging or error codes, because that could be important to you, you can also say, I got the right type, I got the right message. I can test a little bit about the exception that comes back. That's why I said sometimes you might have one or two, because you might have a couple of things in your model that returns or something like that. You could call an exception a model object. But these are the kind of things you can do. You can get improved control flow over your application by not using the expected exception. So, alternatives to exception. We talked about the benefits. It's much easier to read because I don't have to look for that crazy attribute up top. I go back to the 3A pattern. I can identify and isolate code where you actually expect these that's really hard to say. Expect the exceptions, and I can get improved control flow. The liabilities are if you use that assert.throws, the act and arrange are together, or the act and assert are together. That's why I like to record that exception, get it back, validate it's the type that I have, and anything else I like about it. So, number 4. We are cruising through. So we're halfway done for those that are keeping count, because I said there were 6. Small fixtures. So how many people know what a fixture is? A few of you. Well, a fixture is basically just a set of tests. A lot of different testing frameworks will call them a lot of different things. I call fixture because I'm old. At least that's what my kids tell me. I've always called it a fixture. Like I have a set of tests that I want to run together. I call that a fixture. And I like to keep them small because I could create one class and put every single test in there that I wanted to. But it's probably not that practical because it kind of violates all the different rules about how I keep my tests close to the things that I'm testing. That wouldn't work out. So we keep those fixtures small. So what I get as a benefit is a smaller, more focused test class, so I can actually focus the things that I want to. Because I've actually done where I have a class to test a method of another class. Excuse me. So I have one fixture, I should say, to test a method of another class. But there's a lot of different variations that could happen in that method, so I put a bunch of things in the same fixture. And that fixture goes for testing that thing. And then I name it my fixtures appropriately, just as well as I name my tests appropriately. I could get there could be a lot of nested classes. We'll talk a little bit about, I know a lot of people want to probably talk about mocking and things like that. I'm not going to go too deeply into that. But you could have a lot of nested classes, like if you're doing stubs or some kind of mocking to mock out different objects for your classes. So you could have a bunch of one big fixture that creates a bunch of little test classes. Another thing that we did with when I worked in Codeplex for a while is we had a bunch of fixtures that were one big fixture and then a bunch of other little classes in there that did that method testing. So we'd have one class, which was a nested class, that tested one piece about this bigger facade API. So we had a bunch of little nested classes. So we had a big fixture for the facade API, but a bunch of little nested classes so that we could test individual methods of the facade that we put over the entire system. But again, you could end up with some code duplication in there. You could end up with a lot of code duplication in there, which we did. There could be some issues with test runners. Some test runners don't know how to deal with nested classes. I think most of that has been fixed these days. And there's some related issues is about setup and teardown. Well, if you've never seen a real unit test, they also have this idea that, especially in unit testing systems today, that I can do setups for a fixture. I can do setups for the whole kind of test run. And I can have teardowns for those. And what that does is allows you to say, oh, well, I want to move all that code. Maybe you saw that I was testing that stack. And every time I create a stack, well, I don't want to create a stack every time I write a test. Well, I can move that up to a setup so it creates it every time. I'm going to explain to you why that might be a bad idea. Because my personal preference, and over the years I've learned, is don't use setup and teardown. In some cases, they're good. So I actually use unit testing frameworks to write integration tests too. But that's because I'm a dev. That's my tool. That's my hammer. Everything looks like a nail. So I do use it for those when I write some kind of overarching, like acceptance tests, integration tests, where I'm testing all these different things together, and I write a setup and a teardown because I might have to set up some kind of file-based system or something like that. But that's not unit testing per se. So in unit testing, setup and teardown. So when you do a setup and teardown, basically that's what you're doing is you're setting up the fixture to say, hey, I'm ready to run all these tests, and you might set up a bunch of stuff in there, and then you have teardown that says, I'm going to tear everything down that I set up. So if you were doing some kind of database testing, which we'll talk about here in a minute, how you can solve this problem, but I might set up a bunch of column or data in the database so that I can test against it and then delete it all when I'm done. I'm not saying that's a good idea. I'm probably saying that's a bad idea. But you could do something like that with setup and teardown. And why shouldn't you use setup and teardown? Well, what you end up doing is hiding your code. So you remember probably like, I don't know, 20 minutes ago, when I said the first thing I do when I go look at some API or something like that is go look for the tests to find out how they work. I get really annoyed, and this is just because it's me, but I get really annoyed when I go look at it and go, this is how I use it, but then I have to go, all right, split my window, go to the setup, read, all right, this is what I have to do, and set up you have to set it up this way, and then use it this way, and then go scroll some more, set up this way. I'm like, it would be nice if it was all right there together. So that's how I write my code. It does lead to a lot of duplication. Some people don't like that. That kind of violates their don't repeat yourself and all those good principles. But I find that if I can just look at that code and know exactly what I expect it to do and how to use it, I feel much better about that than, oh, I duplicated that line 3 or 4 times. Yes, Scott, you guys are right. When you have to change that one line 300 times, you probably will get annoyed with yourself. But refactoring tools have made that a lot easier. Yes, question?
I was just going to say, you could have your cake and eat it too there, couldn't you? You could refactor those things into little methods, and then they're still appearing in...
Well, I mean, I think the main goal here is what I'm trying to say is, you could anywhere you move that code to, the problem becomes it's further away from the thing that it's testing. And that setup becomes, yeah, and this is just me. If you go out and do unit testing and you use setup and teardown, but you still do unit testing, I'll be happy as a clam. I mean, I'm just saying there's a lot of things that what happens is you also tend to then go, all right, I want to use this setup and teardown to make these fixtures that are huge. I can't make my small fixtures, but when I start moving all this code, because then what my tendency is, because I'm lazy, remember, developer equals lazy. We will spend 3 days writing a program that saves us 3 minutes, right? So that we don't have to do that same thing over and over again. You will start doing that over and over again, and then it becomes kind of a habit. And I try to be very disciplined about, I want to see arrange, act, assert. And that leads to some duplication, and some people may disagree with me, and that's okay. I can completely be wrong, and others can be completely right or wrong. So, number 6, and this is a big one. You guys are all still awake? Raise your hand if you're awake. Okay. Those that didn't raise your hand, just stay snoozing. I'm sorry. So we can talk about inversion of control and improving testability with inversion of control. I'm not going to talk about dependency injection frameworks. If you want to go pick one, pick your flavor. But inversion of control allows us to write better tests. It actually helps us write tests. How many people think they wrote tests to build the WMI objects in .NET, if you've ever worked with WMI objects? I have. I'm pretty sure they didn't. Because writing a test that includes a WMI object is really hard. How many people wrote tests against their system that has databases and they got screwed up because they were running tests at the same times and data, weird stuff you didn't expect? Yeah. Don't run tests against databases. Number one thing, tests should run really fast. Big thing of mine is I should be able to run those tests as much and as often as I want really fast, because why? If it takes a long time, and because I'm lazy, I'm not going to want to wait for it, I'm probably going to stop running them. And that's a bad thing. Because when you start torching your net, you're again on the tightrope without a net. That's not good. So how can I help improve testability with inversion control? We'll specifically talk about like databases, because most of us probably write code and it probably goes against some database and it's doing something. Because these days, all the code we write usually writes database, except for how many people write games? Dang, nobody. Oh, this guy right here. All right, I'll see you afterwards. Anyway, so inversion of control. How many people know what inversion of control is? A few of you. Okay, so this is an article that you can go read about inversion of control. But basically, your inversion of control says, hey, I'm going to tell you what to do or what to use. I'm going to take control. Instead of you being in control, I'm going to be in control. I think of it as, this is what my wife tells me. You think you're in control, but you're really not. I think I'm in control, but I'm really not. So, and there's different ways you could do this with like dependency injection frameworks. So you think of a repository. And if I'm going to create a repository, and I'm going to initialize it with something, I'm going to use a constructor to do that. I can then initialize that with maybe a data context, so that my repository can use a data context. That's kind of inversion of control. Instead of the repository saying, here's the data context I'm going to use when I talk to this database, I can say, here's the data context you should use. So you do operations on the database, but this is the database that I want you to use. That's kind of a contrived example, but is quite important. So inversion of control allows me to start taking control of my program. So I will tell you, the first thing you probably do when you start writing that first test in the code that has no tests is you're going to start unwinding objects. And inversion of control will be your best friend. Because you need to start taking control of how this code gets set up and how things happen within this code. And here's an example. So this is a very old and still very useful example. I have a lister who lists movies from a file-based repository. And there's my little object over there, movie, who describes movies from the repository. So you can see this dependency of file-based repository on movie, and movie lister depends on movie, and he also depends on file-based repository. But what happens when I run my test? Well, for now, it's easy because I'm using a file. I probably can run it against my local system. But what happens when I switch to a database, a real database? And it's no longer a file, it's on some server somewhere, and I want to run tests against that. A, probably not going to run very fast. B, probably going to run into collisions with people like, hey, Joe, down the hall, stop running your test because I got to do mine. Yeah, that never works out. Or over IM. Again, old. This was before IM. That was back in IRC. But with inversion of control, I can do something like this. I can introduce this interface called iMovie repository, and then I can say, test everything against that. So this is where mock objects and stub objects and things like that can come into play. I can then say, let's say I'm testing movie lister, because that's really the guy I really care about. Say, I've already tested out the repository, I feel good about that. I might have some integration tests because it's running in a database, but I'm not running those with my unit tests. I'm saying, I want to test out that I can talk to that movie lister and he will list movies. I like the name movie lister, you know why? Because it tells me exactly what it's going to do. He is going to list movies, or she is going to will list movies. So I'm going to list movies with my movie lister, but how do I test that? Well, I need to kind of tell the movie lister, instead of you using that file-based repository, hey, use this repository. So I'm going to make up my own. Maybe call it in-memory repository. Have a dictionary in there, fill it with a bunch of stuff, and then go, here you go, here's your repository, act on it. And then I can really control right within my test exactly what is going to happen. I can say, all right, you can imagine, let's put on our thinking caps for a second, that I can new up a movie lister. I can give him this dictionary-based repository, movie repository. I can insert into that dictionary-based repository, and what I'm saying is, get me a list. I can expect that if I want to put one in there, one movie to come back. And if that works, and my test pass, check it in. And that's what because that's what we want to do. We want to check in and go home. Play our games from that dude. So that inversion of control really helps you kind of take on this idea of taking control back of your system. Instead of saying, you control what I want to do, I control what I want to do. And then writing that test becomes really easy. And how many people like to write code? I don't know what the rest of you are doing here, but okay. was hoping I'd see everybody, but all right. I didn't see any like people jumping up and down and waving about it, but I like to write code, so writing tests is fun for me. So because I get some more code that I get to write, and then I can test out what my other code is. And I found that over the years, after writing tests, I write less code, a lot less code. Why? Because I already know, especially when I write tests first, this is what I want it to do. Here's the code. It passes. Check it in. I'm done. No more gold plating, no more nothing, no more worrying about all this stuff. Oh, I forgot about an edge case. Well, let me write a test for that. Well, that's going to require me one more line in there. Okay, done. Check it in. Done. Because in reality, my favorite thing is deleting code, but I like to write code too. So, because if I delete the code, it's less code I have to maintain. And man, I'm all about that. Again, because I'm lazy. You see how all this benefits me? And you. But so the benefits are better test isolation. I can set up everything. I can do it right within my test. Done. I can decouple all these class implementations. No longer is people telling me what to do. I really am in control. I got enough of that going home. I have 3 girls. They tell me what to do all the time. But there are some liabilities. There's decreased encapsulation. So you kind of have opened up your systems to these, I can inject anything I want to in there and make it work kind of thing. Yeah. There's interface explosion. That's just because of the language that we live in. But there will be interfaces for a lot of different things. But you might think about this as a smell of, how could I consolidate some of these things? Do I need a repository for every single table? Maybe not. Maybe I can genericize that down into something. I mean, when you start doing these things, you can start thinking about, now I can transform my code. And then you get to really play my favorite game, which is, now I can delete code. Of course, there's related issues to this, which are dependency injection frameworks. I will tell you, for most applications, they are overkill. If you need one, you'll know it. If you have one, you probably don't need it. But that's just my opinion. I could be wrong. So, in summary, just do it. Write that first test. It's easy. It'll be hard at first. It'll take a little pain, but it's easy to write the first test. Making the code work, that's the hard part. Use the 3A pattern. Know what you're looking at. When you go back in 6 months when you have to add a new feature, you know exactly where to go. You look exactly at that thing. You know exactly what's going on. Consistency. Love it. Keep your, because how many people have the tab versus spaces war? I have the 3A war. Anyway, keep your tests close. Use alternatives to expected exception. Small fixtures. Big class files, bad news. Don't use setup or teardown. Improve the testability with dependency injection. Forward. These are different unit testing frameworks and tools. There's Visual Studio. Visual Studio 2011 is going to be awesome. XUnit.net, that's the one I use. I think it's awesome. NUnit, I used to use it too. It's awesome. There's me. These are all the things you can find out about me. Please you'll get this so you don't have to take a picture or anything.